Hi everyone, we'll be solving the fifth worksheet today. So here we have the first question. Okay, we have a recall there. So you should know this binomial equality, okay? So we want to find this term, okay? The coefficient of this term. So we just then want to n minus m to be equal to this, and m to be equal to 99. So here we obtain, and should be, already we know it here, and should be 200s. We just plug the numbers here into this equality, and we get this, okay? So the coefficient of this term is the rest, okay, this. You just know, you should just know this equality. The rest is easy, as you see. Okay, now there's a child and she has n lira. Okay, and we know this fact. Every day she buys either a candy or an ice cream. Okay, and a candy costs 1 lira, and ice cream costs 2 lira. Okay, we want to find a recurrence relation. Okay, and that relation should give the number of the ways that she can spend the money. Okay, and here we know that she has now 10 liras. Okay, for the second part of the question, she will have 10 lira. Okay, by putting this 10 into this relation, we will find the number of the ways that she can spend that money. Okay, now first we will find this relation. So here we have a sub n. We consider it as the number of the ways that she can spend the money, that money, n lira, okay? And we know that if she first buys this candy, okay, we know there will be n minus 1 lira, okay, because candy costs 1 lira. So there will be a sub n minus 1 ways to spend this remaining money, okay, n minus 1 lira. And if she first buys an ice cream, then the remaining money will be n minus 2 liras, okay. So the number of the ways to spend that money is again a sub n minus 2. Hence, we obtain a sub n equals to a sub n minus 1 plus a sub n minus 2. Okay, so why do we add that? Because you can think it like this. So first she will have n lira. Either she will buy a candy, then the remaining money will be n minus 1, and or she will buy an ice cream and the remaining money will be n minus 2. So here we have, or she will have, for this part, there will be again and again some possibilities, okay? So for this part, there will be a sub n minus 1 many ways to spend this lira, okay? And for this part, again, she will have a sub n minus 2 ways to spend that money, this money, n minus 2. Hence, the number of the ways that she can spend this lira, this money, is the sum of a sub n minus 1 and a sub n minus 2. That's why we have this, okay? For this number, you can try a few times to find where it will work, this relation work, okay? So now the second part of the question, she has 10 lira and we will find the number of the ways to spend that money. We see, if we use this relation, a sub 10 equals to a sub 9 plus a8. Okay, so we need to find these values. We start with 0, with n equals to 0. This is n equals to 0, and n equals to 1. Okay, why when n equals to 0, a sub 0 is 0? Because when she has no money, there is no ways to spend that money. That's why a sub 0 is 0. And when she has 1 lira, she can only buy a candy because it costs 1 lira, and she cannot spend her money to buy an ice cream as it costs 2 liras. That's why there is only one way to spend this. When she has 2 liras, then she can either buy a candy or an ice cream. If she buys a candy, the remaining money will be 1, and if she buys an ice cream, then the remaining money will be 0 because it costs 2 liras. And with this money, she can buy again a candy. So this is one way to spend her money. Okay, 2 times she can buy a candy, and this is another way to spend her money. Okay, just only once, buying an ice cream. Okay, so there is 2 ways to spend this money. Okay, the rest we can compute the rest by this relation. So for A3 we have A2 plus A1 by just putting n equals to 3. We get that equality. And we know A2 equals to 2 and A1 equals to 1, so we have 3. And in a similar way, we obtain the rest of the values. And finally, we have A8 equals to 34 and A9 equals to 55. So we have this many ways, or she has this many ways to spend her money. Now, for this part, again, we will find the recurrence relation. Now, to compute the number of bit strings of length n that contain a pair of consecutive zeros. Now, as you can guess, we will consider a sub n as the number of bit strings of length n that contain a pair of consecutive zeros. Now, we want to find a relation. That's why we need to understand what a n represents exactly. So you can think of it like this. So if the last digit is 0, as we want it to contain a pair of consecutive zeros, as we already have a 0 in here in the last digit, then if this is 0, then we won't have anything to do, okay? So if it is 1, then we can either have a 0 in this digit or a 1, okay? By considering these 2 last digits, we will write an exactly, okay? Now let's examine the cases together. So first case is if the last digit, this is 1, okay? Then the remaining string has n minus 1 digits, okay? If this is 1, the remaining, because this is a string of length n, okay? The remaining has n minus 1 digits. So it has so there is a sub n minus 1 possible strings as we desired, okay? Because an represents a string, the number of strings that contain a pair of consecutive zeros. So we can denote the rest as a sub n minus 1. Okay, as we have here 1, then we can denote this one as a sub n minus 1, as in here. Sorry, I didn't see that. Okay. So what if the last digit is not 1? So we did this case. If it's 1, we have a sub n minus 1 digits. Sorry, a sub n minus 1 many possible strings. When the last two digits are 1, 0, okay, when we have now 1, 0, then the rest has n minus 2 digits. So the possible strings, the number of the possible strings is a sub n minus 2 now. Okay, as again we don't have 0, 0 here, we need to consider this. Okay, so we did this case too. Now what about the third case? Now we assume that it ends with 2 zeros. Okay, then for the remaining string, we don't need to have a pair of consecutive zeros as we have here though. Okay, so what do? We just count the number of the possible strings. Okay, so it is, as this can be either 0 or 1, this can be either 0 or 1, we have n minus 2 many digits. So, and for each digit we have 2 possibilities. So there is 2 to the n minus 1 many possible bit strings with ending with 2 zeros. Okay, so here we had a n minus 1, here we had a n minus 2, and this is 2 to the n minus 2. Thus, a sub n equals to the sum of these three cases. Okay. Now, what are the initial conditions? By initial conditions, we mean the natural numbers that you cannot put in the equality. Okay. When n equals to 0, that doesn't hold in the equality. Okay. And when n equals to 0, a 0 should be 0 because there is no bit string with 2 consecutive zeros of length 0. Okay, when n equals to 1, I made a mistake here. It should be equal to 0 also, of course, because there is no bit string of length 1 that contain a pair of consecutive zeros, so it should be 0 again. And n equals to 2, when n equals to 2, there is only one bit string of that contain consecutive zeros, so it is 1. Okay, and we see when when n is greater than or equal to 2, the recurrence relation hold. So these are the initial values, a0 and a1, because the rest holds. Okay, so a1 should be 0 here. Okay, I didn't make the same mistake there, so okay, so the result is correct then. Okay, now we compute the number of bit strings of length 7, okay, that contain 2 consecutive zeros. So we need to compute a sub 7, which is equal to a sub 6 plus a5 plus 2 to the 5, because remember the relation, we put n equals to 7 and get a6 plus a4, sorry, a6 plus a5 plus 2 to the 5. Okay, here we have. So we just need to compute these ones. As in the previous question, we do the same thing. We just use the relation and put the values of n and get this number. And this is another question. This question actually is similar with the fifth question, I guess. Yes, it's similar with this. So here we have we have n stairs, okay, and a person will climb these stairs, and each time either the person take one stair or two stairs, okay. So exactly this is similar to the fifth question. So because you can think it like this, n pairs, either when the person takes one step, the remaining steps will be n minus 1 many, and if he or she takes two steps, then the remaining will be n minus 2. So the number of these ones a sub n minus 1, and the number of these ones a sub n minus 2, because we consider an as the number of the ways to climb the stairs, okay? So we have here n sub n minus 1, n sub n minus 2. The sum of these will give us a sub n, okay? So this is the relation. Okay, now what are the initial conditions? We see a0 should be equal to 1, as if there is no stair, okay, if there is no stair, there is only one way to do. What's that? It's to do nothing, okay? So a0 is 1, okay? And what is a1? If there is only one step, then he or she will climb this one only. So there is only one way to climb it. So a1 and a0 are the initial conditions. And whenever n equals to 2 or greater than 2, this relation holds. So these are the only initial values. Now we have 8 stairs, okay? So what does it say? You should compute a8. I don't do the same thing, so you just put n equals to 8 and compute the rest, okay? And this is the last question. Now we have a string, okay, that contains only zeros, ones, and twos, which is called ternary string, okay? We will find the relation again for the number of these strings, these such strings of length n that does not contain, okay, two consecutive zeros. Okay, we will find the number of ternary strings of length n that does not contain two consecutive zeros, okay? So again, as you can guess, an represents the number of the ways, the number of the ternary strings of length n that does not contain two consecutive zeros, okay? So what do we do? Again, we will examine the cases. So first case is to have a 1 in the first digit, okay? If we have a 1 here, then the remaining strings, the remaining digits, the remaining string has n minus 1 digits, sorry. So there is a sub n minus 1 ways to complete these strings, okay, to finish it, okay, if we have 1 here. And if we have 2, again, as in the previous case, we have again a sub n minus 1 ways, because we had 1 there, okay, the rest will be containing the two consecutive zeros, and this number is represented by this a sub n minus 1. And again, if we have 2, it's represented by the same number. So what if we have 0 here? Then this the second digit can be either 1 or 2, right? because we don't want it to contain two consecutive zeros. So it can be either 1 or 2. So if it's 0, we have, for example, if we have 1, 1 here, okay, if we have 1, 1, sorry, if we said 0 already, let me write it first, okay. We can have either 1 or 2. If it's 1, the remaining will be a sub n minus 1 ways can be finished. And for if we have 2, again we have a sub n minus, it is 2, sorry, it is 2. So a sub n minus 2 ways it can be finished. So for each one we have the same number. So we have in this case 2a sub n minus 2 ways to have these such strings. Okay. If we fix 0, and for 1 we have, why do we have only 2 possibilities for this digit? Because we don't want 2 consecutive zeros. That's why this is not a case here. Okay, either it can be 1 or 2. So there is n minus too many digits here. So we have this. Okay, for these two cases we had 2a sub n minus 1, and here we have 2 sub a sub n minus 2. Okay, this is the relation. So what are the initial conditions? When we put n equals to 0, we have 0 because of length 0 there is no such string. And when n equals to 1, we have 3 because, as you can imagine, there is 1, 2, or 3. Okay, these are the digits of length 1, and they don't have any consecutive zeros, so we have 3. And a2, it is 8. You can just do that by yourself, okay? You know that. You can already use permutation, okay? And you see when n is greater than 3 or equal to 3, this relation holds. So these are the only initial values. Okay. And for 6, the length 6, we need to compute this one just by plugging n equals to 6 here. Okay, we need to compute this one. So we know a0, a1, a2, and we just compute these ones by using this relation. Okay, hence we have this number. This was the last question. If you have any question, you can ask me on Fridays at the office hours, which is between 5 p.m. and 7 p.m. Okay, see you there. Take care.